All right, well, good evening, everybody.
Good evening, sir.
Welcome to the McCarthy Observatory and our second Saturday Stars presentation for April. So it's good there's not a line outside, so I'll go as quickly as I can, but it's a longer presentation than it probably should have been. So,
What lights on?
pardon me?
Lights on?
Sure, if you want. It's up to you. I don't care. Okay, so this is the Hubble Ultra Deep Field image taken a while back, and everything you see there are galaxies. NASA says there's 10,000 galaxies in there, and it's looking back almost to the Big Bang. So there's a lot of galaxies with a lot of stars in that one picture. This is a picture of a galaxy that was taken from here with our telescope by Mark Polanski, one of our volunteers and board member. And it's just a gorgeous picture of a big, close galaxy, about it's about the size of the Milky Way, maybe a little bit bigger. But on a good clear night with dark skies, you can see it with your naked eye. At least I used to be able to. This is another picture by Mark. This was taken up at his home on a beautiful clear night, he said. And it's a portion of our galaxy, the Milky Way. And look how many stars are in there. So the universe is a big place with a lot of stars. And we know now that most all of them have planets. Here's another picture. This, I can tell you, was taken on Valentine's Day of 1990. That's a picture of us. That's us right there in a sunbeam. That's the Earth from Voyager 1. Carl Sagan convinced the Jet Propulsion Laboratory to, since the main missions of the Voyagers were completed, to turn the Voyager 1 around and take a family portrait of the planets in the solar system. So they did, and this is taken from outside Neptune's orbit, 4 billion miles from Earth, a picture of the Earth. It's just one pixel on there. Here's a little bit of a close-up compared to the last picture. This is from 2,500, 250,000 miles away. This is the Earth from Apollo 11, our first manned landing on the moon in 1969, in July of 69. And here's my favorite picture of the Earth. This was from our last manned voyage to the moon from Apollo 17. This was taken from 28,000 miles up, and it really is a special picture. They couldn't have done it better. So right in I don't think this is going to work, is it? No. Right up in there, in that dark spot in the middle of Africa, that's where science says we began. Homo sapiens began in that part of Africa and then expanded out over the world. Then right up at the top of that picture is where civilization began, in Mesopotamia, in present-day Iraq, and the rest of the Middle East up there, where there's a ongoing genocide, unfortunately. Then, down at the bottom is Antarctica, a large continent down there that if all the ice on Antarctica melted, it would add 60 meters, about 200 feet to the level of the oceans. And, it won't take much more to get it to melt. Now, it's not going to melt quickly. It'll take thousands of years for all of that ice to melt, but if the temperature gets hot enough, it will be irreversible. 200 feet at sea level, there goes almost every major city in the world. New York, it's about 10 feet on average above sea level. Washington's a little bit more, maybe 60 or 80. And San Francisco's gone, Los Angeles, the airport's 126 feet above sea level. So, every major city you can imagine will be underwater. Let's see, where am I doing? So this beautiful Earth is the only place in the entire universe that is known to have life. We now know that most stars have planets, and we've been searching for life in the universe for decades with negative results. This tells me that life, all life, is precious, and we should treat it as such. In spite of science fiction, there's no other planet that we can live on. As Carl Sagan said, like it or not, here's where we make our stand. Here's some of the other life forms that we share this beautiful planet with. This was taken right out here. I'm not sure who took it, probably Bob Lambert, or he's responsible for it anyway, but he called it a frequent visitor. And this is on our website. But does it get any cuter than that? Here's another picture. Look at that. From right out here. A monarch butterfly on a beautiful flower. So life is precious. This is the only place that we know has life. Unfortunately, the current state of the Earth is dire. So I'll talk about many of the threats that we're facing, some existential for humanity, but since they are all caused by us, we can change the course that we're on. This, when I first saw it and thought about it, brought tears to my eyes. So, this is the extent to which current and future generations will experience a hotter and different world depends on the choices we make now and in the near term. So it starts down here. If you were born in 1950, and as you get older, in 2020 you'd be 70. Well, in 2020, I was older than 70. I'm 78 now, but I don't have a cane. Most of my children were born on either side of 1980. And when they get to be 70 years old in 2050, the Earth on the course we're on now is likely to be 3 degrees hotter. 3 degrees hotter is an emergency. photosynthesis stops at about 100 degrees.
Monty, may I ask a question?
Yeah.
Is that 3 degrees Fahrenheit or Celsius?
No, everything in here would be
Oh,
Celsius.
so that's a lot.
So, but this is what brought the tears to my eyes. Most of my grandchildren were born around in this area. I've got 3 beautiful little granddaughters. The twins are 5 and the older one is 6. So when they get to be 70 years old here, right around 2090 or so, look at that. That might be 4 degrees hotter on the course we're on now. It's a disaster. This is the doomsday clock. This came out January 28th of this year. The end of January every year, the Bulletin of Atomic Scientists sets what they call the doomsday clock. That's a metaphor for catastrophe. So when it gets to midnight, that's supposed to be catastrophe. This is the closest to midnight this clock has ever been since they started in 1947. And Albert Einstein and Robert Oppenheimer started this atomic scientists. So what they do, they look at the nuclear war risk, they look at climate change, they look at emerging technologies and things like that. So we're in the midst of several global emergencies, including climate change. We're in the midst of the 6th mass extinction. We've got a rapidly growing population. When I was born in 1946, the population of the Earth was 2,400,000,000. Yesterday, according to the U.S. Census, the population of the Earth was 8,111,000,000 and some change. Right? So a rapidly growing population. We're depleting the soil. Natural resources are being depleted. We're deforesting the planet. We're over pumping from ancient aquifers, so fresh water's in trouble. We're overusing fertilizers and poisons, other pollutions. We're overfishing and hunting, and we're diverting grain for livestock feed and for biofuels. The greenhouse effect was first brought up by Joseph Fourier in 1824, and then experimented on by John Tyndall in 1858, and reported quantitatively by Svante Arrhenius in 1896. Here's Fourier in 1824. He published this paper in this respected French scientific journal on chemistry and physics from Paris in 1824, and I'm not fluent in French, but you can kind of guess what it says. General remarks on the temperatures of the terrestrial globe and spaces. Well, anyway, it was then translated by a tutor in Amherst University and sent down to New Haven to Benjamin Silliman at Yale, and he put it in the American Journal of Science, which is still being published. It's the oldest scientific journal in the United States. So climate change, or man-made or anthropogenic climate disruption began with the birth of civilization over 10,000 years ago and the agricultural revolution. The Industrial Revolution, since about 1750, has greatly accelerated climate change. The burning of fossil fuels produces carbon dioxide. 1 gallon of gasoline adds more than 19 pounds of carbon dioxide to the atmosphere when burned. Carbon dioxide is transparent to the incoming solar radiation. So the sun's rays hit the earth and they warm the earth. But the earth, like anything else, tries to get to thermal equilibrium, so it radiates the heat back towards space. But that's in infrared radiation. And infrared radiation is absorbed by these greenhouse gases, carbon dioxide being the major one. So the Earth tries to cool itself off, and the carbon dioxide stops it. It's like a blanket over Earth. So this warms the planet, which we've known since 1824. Now, carbon dioxide stays in our atmosphere for centuries. It doesn't disappear quickly. Not easy to get rid of it. So how can a gallon of gasoline produce 20 pounds of carbon dioxide? Well, it's simple physics and chemistry and math. So, yeah, the carbon comes from the gasoline, and it combines with 2 atoms of oxygen, which are bigger and heavier. And so altogether, you do the math, it weighs almost 20 pounds, not quite 20 pounds for a gallon of gasoline. So you think of that the next time you're stuck in traffic at a standstill and just idling your engine. Here's what's called a Keeling curve by Charles Keeling. Started it in 1958 when the level of the carbon dioxide was down about 310 or so parts per million in the atmosphere. And he did it at Mauna Loa on the big island of Hawaii, which has the cleanest air in the world. And so he's been doing it all the time. He passed away, unfortunately, in 2005. His son took over doing it. But you notice it's a exponential curve. It's not just getting bigger, but it's getting bigger faster, exponentially. And that's the scary part of it. And you notice it has a sawtooth pattern to it. Well, the top of the sawtooth is right about now, in early spring in the northern hemisphere. And the bottom of it is in October, end of October. You say, well, that doesn't make any sense. Well, it does when you know why. This is photosynthesis, folks. That's taking from the peak down to here, from April or beginning of May to October. That's summertime. That's growing season in the northern hemisphere. And that's the trees and the plants, through photosynthesis, removing the carbon, a good deal of the carbon dioxide from the atmosphere. And how do we know that? It's easy. Here we are looking down from the North Pole on the Earth. There's a heck of a lot of land there. There's a lot of land. But if you look, whoopsie, come on, from above the South Pole, what do you see? You see Antarctica and just a little bit of land. So there's not that much land down there where there's photosynthesis happening. Some of the risks of climate change: global warming, more damage from stronger storms, sea level rise, acidification of the oceans, species extinction, droughts, heat waves, wildfires, floods, freshwater shortages and droughts, food shortages, increasing violent conflicts like going on all over Africa now, and human health issues or worse. Here, the date on this, March 19th. The World Meteorological Organization reports spiraling weather and climate impacts. The clear signs of human-induced climate change reached new heights in 2024, with some of the consequences being irreversible over hundreds, if not thousands, of years. The State of the Global Climate Report confirmed that 2024 was likely the first calendar year to be more than 1.5 degrees Celsius, 1.5 Celsius degrees above the pre-industrial era, with a global mean near surface temperature of 1.55 above the 1850 to 1900 average. This is the warmest year in the 175-year observational record. The report also showed that atmospheric concentration of carbon dioxide is at the highest levels in the last 800,000 years. Globally, each of the past 10 years were individually the 10 warmest years on record. And then the ice. Each of the past 8 years has also set new records for ocean heat content. The 18 lowest Arctic sea ice extents on record were all in the past 18 years, and on and on and on. There's no question global warming is not a hoax. Here's the global mean temperatures from 1850 to last year, calculated by 6 different organizations. And look how well they all agree with each other. Global warming is not a hoax. And it's not free. This is last year's billion-dollar weather and climate disasters in the United States. Last year was not a good year for climate disasters. And this year is not either. They're calling potential billion-dollar events. Well, baloney. They all were, and maybe more. The Los Angeles wildfires in January, holy moly, that might be $1 trillion by the time we're done with it. The southern and eastern severe weather in March, central and southeastern tornado outbreak in mid-March, and then this last one last week or in early April, historic flooding with more than 100 tornadoes and 20 or so deaths that we know of. They've been doing this billion-dollar loss from weather and climate disasters. They've been keeping track of it since 1980. This is NOAA doing it, the National Oceanic and Atmospheric Organization, which made the news today that they're cutting back the staff and the funding for. That's great. This, by the way, the costs are inflation is taken into account on there, so the CPI is figured in, so it's not that these numbers are inflated. They're corrected for that. But look, this is all increasing. I guess does not work. Oh, there it is. Isn't it? No. Anyway, in the decade of the 80s, there were 2.5 events per year, and the costs per year, the losses were over $20 billion per year. The deaths per year were 271. Then in the 90s, they go up a little bit. 4.1 events a year, almost 30 billion costs per year. The 2000s, they go up more. Okay. Now the cost per year is up to 55 billion and 280 deaths per year. The 2010s, again, it increases. Almost $80 billion every year we're losing to weather-related events. And look, last 3 years, cost per year 112 billion. Last year, 2024, we lost 517 people. We lost $136 billion in damages. So don't tell me climate change is a hoax. Here's last week in Kentucky. Look, this is flat ground, and look how much water is there. Now, this is either last year or maybe 2023 in California, the forest fires, the wildfires. Here's Typhoon Yagi that hit South Asia last year. 700 lives lost. All right. Climate change can bring on conditions exceeding human thermoregulatory capacity. Okay, this is interesting. There's more to this than you think. So this is historically the way things have been, and then this RCP is the code that the Intergovernmental Panel on Climate Change uses. So this is if we can get our emissions down to just a little bit. This is, they think, maybe the average, and this is really their highest rate of greenhouse emissions that they consider. But I'll tell you what, this is what we've been doing for several years, and higher than this. So look at this. What the color coding is number of days per year above deadly threshold. Number of days per year. And so, look at this color. The dark red is every day of the year. Right? 365 days a year. This dark red here in the Amazon and equatorial Africa, parts of India, down through Indonesia and part of New Guinea, and part of Australia. Every day of the year, it's too hot to be outside. And we're exceeding these temperatures now. But I also want you to know a couple years back, they were saying that the hottest temperature that people can stand is a wet bulb temperature of 35 degrees Celsius. Body temperature is 37 Celsius, 98.6 Fahrenheit. But now they've reduced that a lot. They've done, I don't know where that number came from, but 35 Celsius is much more than we can stand with a wet bulb temperature. So what that means is the way they figure out relative humidity, they compare the regular thermometer, which is a dry bulb, and then they have a thermometer that has a fabric covering over it that's wet with water. And the water evaporates and cools that thermometer down some. But now they say it's somewhere between 26 Celsius and 32 Celsius is all we can stand. And I'll tell you why. So in 2007, in August, I was at a conference in Tucson, Arizona. And I walk regularly, so I went out for a walk one day. And as I left the air-conditioned hotel, there was a big sign up there with the temperature on it. It said 102. And I said, hot. And it felt hot. I walked down the hill and walked back up as fast as I could, about 3 miles altogether, and not one bit of sweat. I thought, geez, that's funny. I'm not sweating. And I was moving out. Well, I was sweating like a pig. But it was evaporating immediately and cooling me off because the air was so dry. That's the heat of evaporation, the latent heat of evaporation. To evaporate, it takes heat, energy. So when it does evaporate, it cools you off. That's why you sweat. That's our method of keeping our bodies at our normal temperature. But when it's very humid, you sweat. If I'd walked around here when it's 75 or 80, I'd be drenched, because you sweat and it doesn't evaporate. So if it doesn't evaporate, it doesn't cool you off. So watch it when it gets hot, folks. The conditions under which humans can effectively regulate their body temperature are actually much lower than earlier models suggested. And here they go into it and say that somewhere they say that it's down to between 26 and 32 Celsius for a wet bulb temperature. And countries are already experiencing significant health system disruptions. That was 2 days ago. And this is in February. I'm talking about biodiversity and the spillover of infections from animals to people. And here they say, and this is something I didn't know of until just a couple days ago, but I did in Bill Cloutier's amazing newsletter. Scientists blame climate change for spread of infectious diseases and unleashing of ice-blocked microbes in the Arctic. So it's getting so warm that the permafrost is melting. And here's a scientific paper just put out. environmental stressors and zoonoses in the Arctic. Zoonoses is diseases that come from animals to man. Learning from the past to prepare for the future. And here's all the authors that did it and all their credentials and affiliations. Here's the abstract. I'll read a little bit of this. About 3/4 of all known human infection diseases are zoonotic, and potential health impacts from these diseases are higher where infectious disease surveillance and access to health care and public health services are limited. Well, that's obvious, right? This is especially the case for remote circumarctic regions where drivers for endemic, emerging, and re-emerging zoonotic diseases include anthropogenic, that means people-made, influences such as pollution by long-range transport of industrial chemicals, climate change, loss of biodiversity, and ecosystem alterations. In addition to these, indirect effects including natural changes in food web dynamics, appearance of invasive species, and thawing of permafrost also affect the risk of zoonotic spillover, disease spillover. In other words, the Arctic represents a changing world where pollution, loss of biodiversity and habitat, and marine activity are likely driving forward the occurrence of infectious diseases. So some people are calling them zombie viruses that when the permafrost thaws, they can activate. This is a chart by a scientist that I greatly admire. His name is Johan Rockström. He was a Swedish guy who worked in Stockholm for years, and now he's director of the Potsdam Climate Institute in Potsdam, Germany. And this is his doing. He calls it the planetary boundaries. He's got 9 different items that he says are boundaries that we're in trouble if we cross. So if they're in the green zone, that's good. If they're out in the red zone, that's not good. That's crossing the boundary. And in between, the orange is kind of getting serious. So here's what they say in their latest doing of the planetary boundaries. Climate change, atmospheric CO2 levels are at a 15 million year high. Remember the IPCC said it was 800,000 years. Here they're saying 15 million years. The CO2 hadn't been as high as it is now. And they know that from ice core data and a lot of other things, a lot of other methods that they have to figure that out. And it's accelerating. Global mean temperatures are now higher than at any time, any point since human civilizations emerged on Earth. In other words, in the last 10 or 12,000 years since the agricultural revolution in Mesopotamia. The change in biosphere integrity, that's way out of bounds now. The global loss of genetic diversity and the loss of functional integrity is no good. The land system change, we're cutting down the forest, even the Amazon, which some people used to call the lungs of the earth. And they're doing it primarily for agricultural reasons to feed us. The freshwater changes, they're over pumping, and streams are, some of them, getting contaminated. The modification of the biogeochemical flows, what he's talking about there is mostly the nitrogen and the phosphorus in our fertilizers. The farmers are using that indiscriminately and to make their harvest, and it's running off, getting into the streams, flowing into the rivers, flowing down through the estuaries into the ocean, where they're creating algae blooms that suck all the oxygen out of the water, and the fish die, and the other creatures at the bottom die. They're dead zones in most of the world's major estuaries. There's a dead zone now because of fertilizer. And then also the novel entities. These are mostly chemicals that are being released into the environment that have not been tested on their effect into the environment. And we do a lot of stupid things. And this just shows that the ones in red are the ones that are over. So there are three things that are not have not crossed the planetary boundaries now, and that's ocean acidification, although it's getting close. The increase in aerosol loading of the atmosphere, which is the particulate matter, especially the tiny, small particulate matter that comes from a lot of different places. From forest fire smoke is one, from exhaust from the cars and trucks is another. And then the stratospheric ozone depletion. We'll talk about that in a minute, but it's well down from the planetary boundary. So here's the trends since 1750, which was the beginning of the Industrial Revolution, in the socio-economic trends, everything. Those are exponential growth curves, and just about everything is going up. Here's the Earth system trends. The greenhouse gases on the top, they're all going up exponentially. Temperature, ocean acidification, just everything going in the wrong directions for life. Here are the species extinctions that are accelerating globally. So the top one is all the vertebrates. The mammals is down here on the green. Now let me say something about mammals. Only 4% of the mammals alive on Earth are wild. 96% of the mammals on Earth are either humans or human livestock. Here's the global forest declines from the whole world, the boreal forest, the northern forest that was burning year before last so much in Canada. The temperate forest around here and the tropical forest, they're all below the boundary. Here's the Living Planet report that comes out every other year from the Panda people, the World Wildlife Fund. They do a real good job with it. So they say that since 1970, we have lost 73% of the population of vertebrates on the Earth. 73% since 1970. Restoring nature demands urgent transformation. It's not too late to save our living planet, but it will take some big changes, as well as making much greater efforts to conserve and restore nature. We need to tackle the causes of its destruction by transforming our food, energy, and finance systems. So, changes in the global value of the ecosystem services. So, this says, and this is a little bit old now, this was in 2014 that this was calculated, but it's been calculated before this and since. Eco services, that's what nature provides, contribute more than twice as much to human well-being as global GDP. Twice as much we get for free from nature as is all the products of all the goods and services in every country in the world. They clean our air, the plants do. They clean our water. They give us food. They do a lot of water to drink. A lot of things. Nature is important, and we inherited the Garden of Eden. We really did. And we're trashing it just as fast as we can. The effects of defaunation on plants' capacity to track climate change. Defaunation means doing away with animals. And what it's saying here in this paper is that since the animals, birds and animals, are reduced in number, that the plants pretty much stay put. They don't move, or a lot of plants don't. Birds will eat the seeds and then drop them somewhere, or a bird gets stuck on an animal and carted somewhere else. So just the animals' interaction with the plants spreads their seeds over a wide area. And so if it's too hot in one place and the seed gets dropped up on top of a mountain or further north or whatever, it can grow. So because we're losing animals, we're also losing plants. This is the latest from the Intergovernmental Panel on Climate Change of the United Nations, their synthesis report 2023, their summary. This is the latest one that they have. This the sixth of their reports. So observed warming and its causes. Human activities, principally through emissions of greenhouse gases, have unequivocally caused global warming, with global surface temperatures reaching 1.1 Celsius degrees above the 1850 to 1900 average. So again, it's not a hoax. The widespread and rapid changes in the atmosphere, ocean, cryosphere, which is the ice, and the biosphere have occurred. Human-caused climate change is already affecting many weather and climate extremes in every region across the globe. This has led to widespread adverse effects and related losses and damages to nature and people. Adverse effects from human-caused climate change will continue to intensify. Future climate change, yes. So what they say is deep, rapid, and sustained reductions in greenhouse gas emissions would lead to a discernible slowdown in global warming within around 2 decades, and also to discernible changes in the atmospheric composition within a few years. Now, we're not going to spend much time on this. What does it say? It says, with every increment of global warming, regional changes in mean climate and extremes become more widespread and pronounced. Yeah, okay, so we can understand that. But the opposite is also true. Every incremental decrease will help out. So limiting warming to 1.5 degrees and 2 degrees involves rapid, deep, in most cases immediate greenhouse gas emission reductions. Okay. Here's the urgency of it. Yeah, okay, we understand that. Climate resilient development integrates adaptation and mitigation. So when the IPCC says adaptation, what they mean is adapting to the climate change that's already happened. Like building seawalls to keep the ocean out, or things of that nature. Mitigation means reducing the causes of the warming. That's the way they use those two things. So mitigation is obviously the better part. Stop the emissions or slow them down rather than try to keep the sea out. There's a rapidly narrowing window of opportunity to enable climate resilient development. But here they list the things that we can do that enable climate resilience. And here are the things that we shouldn't do. So there's a lot of things that we know about that will help. We know what to do. We just need to figure out how to get things done. The benefits of near-term action: deep, rapid, and sustained mitigation and accelerated implementation of adaptation actions in this decade would reduce projected losses and damages for humans and ecosystems and deliver many co-benefits. Everything we can do, every little thing that we can do to help is going to help. Again, multiple opportunities for scaling up. We're not done for. We're in a serious position, but we're not done for, folks. All sorts of things we can do. Equity and inclusion. This will help. Prioritizing equity, climate justice, social justice, inclusion, and just transition processes can enable adaptation and ambitious mitigation actions and climate resilient development. The opposite of what we're hearing on the news every day about DEI. DEI is good, and not just good, it's necessary. This is something a little bit different. These are the SDGs, the Sustainable Development Goals that the United Nations wanted done by everyone by 2030. And we haven't done much, but they're important and it should be done. No poverty. That's important. You think, oh, well, why bother? Jane Goodall, who studied our closest relatives, chimpanzees, in Gombe National Forest in Tanzania, when she started many years ago, when she was not much more than a teenager, it was a lush natural forest. And then I saw pictures of it in a video about her recently, and where she had been working was like a desert, because the poverty in that country was so much that the people living there had to cut down the forest to use for fuel, to use for building materials for their houses, and to sell as firewood and things like that. They turned it into a desert because of their poverty, because they couldn't afford to buy things. So poverty is number one. Zero hunger. That's important. Good health and well-being. Quality education. Gender equality. Clean water and sanitation. Affordable and clean energy. Decent work and economic growth. I wish they had said economic development instead of growth. Industry, innovation, and infrastructure. Reduced inequalities. Sustainable cities and communities. Responsible consumption and production. Climate action. Life below the water. Life on the land. Peace, justice, and strong institutions. And partnerships. Working together. We all live on this planet. This is Bandy Lee. She is a psychiatrist. She, you might remember, wrote a book about the 45th president and his problems. They diagnosed him. Anyway, she says that we need one world or we're not going to have any. In other words, we have to get together as people, we're all human beings, all over the world, and work on the problems. Or else we're not going to have any. And anyway. So we can deal with all of the threats that we're facing because they're all man-made. Some will be easy to fix, and others will be more difficult. Oftentimes, when dealing with complex problems, the correct solution seems to make things worse in the short term, but will work with time. We have solved two major problems in the past. Major problems. The Dust Bowl and the stratospheric ozone depletion. Look at this. That's a farm, I think, in Oklahoma or Kansas. And look at it. That's sand. That's dust that is drifting like it was snow. Look, that's a farm, and you see the trees up above it, but you don't see anything growing there, right? Look at this. Dust Bowl farmer raising fence to keep it from being buried under drifting sand from Cimarron County, Oklahoma. The cow doesn't look very happy. And you've all seen this picture. Destitute pea pickers in California. a mother with 7 children, age 32. Dust storm approaching Spearman, Texas, April 14th, 1935. In 2 days, it'll be 90 years old, that picture. Look at that. Look at that one. Now this dust, I mean, there were days that it looked almost that bad in Washington, D.C. But that dust didn't just land on the outside of the houses. It blew through the, underneath the windowsills and the door sills and any opening that could possibly, and there were inches of dust throughout the houses. I don't know how they breathed. I don't know how they did, but, that dust ball was really something, and it was completely man-made. A lot of it was from the rich people that owned the farms, that never visited the farms. They didn't work there. They just owned the land and had tenant farmers farming it, and so they destroyed the natural prairie grasses that had lived there for thousands of years and produced super rich soil. Beautiful, dark carbon in the soil. But they plowed it all up and put in wheat primarily, corn in some places. And then they had a dry spell, and the winds just started blowing it, and blew sand and stuff on the crops and buried the crops, and it just kept getting worse and worse. And finally they figured out what to do, to contour plow and to irrigate when they could, and this and that, and we did solve it. The other one was ozone depletion. So in the early or mid 80s, they discovered that that some of these chemicals we're using, if they got into the stratosphere, would destroy the ozone. So very shortly after science showed that CFCs, which are chlorofluorocarbons, and some other man-made chemicals, halogens and stuff, used in refrigerators, air conditioners, and the spray cans, were destroying the stratospheric ozone layer that protects life on Earth from deadly ultraviolet radiation from the sun. Most of the ultraviolet is taken out by the ozone layer. Ozone is just oxygen. It's 3 molecules of oxygen together instead of the normal 2 in the lower atmosphere. But some of the ultraviolet gets through, and it's not good for you. It's not good to get a sunburn. But without the ozone, it would reach deadly levels pretty quickly. But anyway, the world came together in the 1987 Montreal Protocol on substances that deplete the ozone layer. So the whole world got together and very, very quickly ratified a treaty to stop doing this. And that's why if you go to the recycling center in New Milford with an old air conditioner or a refrigerator or something, they're going to charge you quite a bit of money because they have to very carefully withdraw the CFCs from it. So, but a new threat has been discovered as low Earth orbiting satellites as their orbits decay and they re-enter the atmosphere, the great amount of aluminum oxide produced, it's microparticles, and they slowly descend through the ozone layer and destroy it. And so these dopes that are putting up these constellations of satellites in low Earth orbit, like the Starlink, they're primarily made out of aluminum. There's other stuff in them too. But when it burns up in the atmosphere, it produces aluminum oxide, and that is a catalyst to destroy the ozone. So we don't need all that stuff. It doesn't do us any good here at the observatory when we're trying to get a nice picture and a satellite goes through the camera field. Anyway, we don't need them. Some we do. Some are very important for us. They're monitoring the Earth that NASA puts up, but these little Starlink things and all that, that's absolutely unnecessary. So, anthropogenic climate disruptions and the other threats we are facing can only be slowed or stopped if all of us work towards that goal. We need to educate ourselves about the issues, discuss it with others, write, email, and call our government representatives, get out in the streets and protest for Earth. This is our only home. We only have one chance, folks. And be as kind to the environment as we can in our daily lives. This is one other thing I wanted to read a little bit of. The trajectories of the Earth system in the Anthropocene. Anthropocene is what a lot of scientists are calling the age we live in. It's still technically the Holocene. And the people that figure that out, there's an international stratigraphic council or something. And it's based, the different ages of the Earth are based on the layers in the Earth. And so they're having a trouble calling this the Anthropocene, which means the era when man is the biggest changer of the Earth, instead of the Holocene. But this is an important paper on it, and I'll read a little bit of the abstract here. It says, we explore the risk that self-reinforcing feedbacks could push the Earth system towards a planetary threshold that, if crossed, could prevent stabilization of the climate at intermediate temperature rises and cause continued warming on a hothouse Earth pathway, even as human emissions are reduced. Crossing the threshold would lead to a much higher global average temperature than any interglacial in the past 1.2 million years, and to sea level rises significantly higher than at any time in the Holocene. So anyway, they're saying if we're not careful, if we cross these thresholds, we might force the Earth into a really hot position, more so than you would think it would be. But so that abstract is a polite way of saying we the people must change our ways. We in the U.S. must take back our government so that it really is of the people, by the people, and for the people, and will not perish from the earth. We need major reform to the neoliberal capitalist corporate economic system currently in use. It is impossible to have continuous growth. That's what they always talk about, growth, growth, on a finite planet. It's impossible. Think about it. So with that, I'm going to read a little something that I don't think many of you have read in a while. some of you maybe never, our founding document, the Declaration of Independence. Thomas Jefferson said, "We hold these truths to be self-evident, that all men," he didn't say women, I don't know why, but back then it was just men that ran the world. Hopefully we can modify it. That all men are created equal, that they are endowed by their Creator with certain unalienable rights, that among these are life, liberty, and the pursuit of happiness. That to secure these rights, governments are instituted among men, deriving their just powers from the consent of the governed. That whenever any form of government becomes destructive of these ends, it is the right of the people to alter or abolish it, and to institute new government, laying its foundation on such principles and organizing its powers in such form as to them shall seem most likely to affect their safety and happiness. Prudence, indeed, will dictate that governments long established should not be changed for light and transient causes. And accordingly, all experience hath shown that mankind are more disposed to suffer, while evils are sufferable, than to right themselves by abolishing the forms to which they are accustomed. But when a long train of abuses and usurpations, pursuing invariably the same object, evinces a design to reduce them under absolute despotism, it is their right, it is their duty to throw off such government and to provide new guards for their future security. That's what the Declaration of Independence says. And we're very close to absolute despotism. This is the last thing, and let's see. I'm not sure how to get it going here. Oh, wait, here we go. Can I? Yeah, okay.
One day, we will wake up to find that the energy that powers the alarm clock came from the breeze through the trees the night before. And we will go to work that morning riding the rays of the sun. It will light our cities and power our businesses. It will warm our homes and cool our workplaces. It will reduce sources of conflict and fuel our economies. It will connect us all. It won't scar the land or poison the seas. The food we eat will be good for our bodies and good for the planet. And the weather that day won't make us worry for tomorrow. There will be more jobs and less disease. The sea level will stop rising. And species will stop dying. The question is, how do we get to that day from where we are today? All 7.3 billion of us. We start by deciding that beyond our doubts and differences, such a day truly exists. And that is something each of us can do today. We can make today the day we stop thinking that the changes required to get there are impossible and beyond us, and start realizing that they are not only possible, but what the future requires of us. We must stop turning from the warnings of science and fear and denial, and instead turn toward the solutions and partnerships we need. We can make today the day we stop pointing at each other in blame, and instead chart a new course together. We have never faced a crisis this big, but we have never had a better opportunity to solve it. We have everything we need to wake up to a different kind of world. We need our leaders to be brave and their choices to be bold. They will either remember us as the generation that destroyed its home, or the one that finally came to respect it. We have every reason in the world to act. We can't wait until tomorrow. This is our only home. You can choose today to make a world of difference.
So, thank you.
Thank you.
It's important topics we're dealing with. It's really has to do with whether we make it or not, and we've got to do it. I'm committed because of my little granddaughters. I'll do everything I can to do it, including give long-winded talks. So I'm sorry it took so long, but there's some points that I just wanted to make. And,
Wasn't that long? You did a great job.
well, all right, well, thank
We
you.
have to be better stewards of our time.
We really do. Yeah.
And much.
So if you have any questions, I'll try to answer them. I don't know everything, but anyway, thank you.
Thank you.
Thank you, Monty.